Troubleshooting RIP version 2. I'll tell you one thing about RIP version 2. It beats static routing, right? And it's ubiquitous, meaning it's supported all over the place. A lot of times vendors like Cisco will create small business gear where you can get like a layer 3 switch for a couple $100, but they'll limit the feature set to where it only supports static routing in RIP. And I've been in situations where I've been supporting a company and they're trying to make it all work together and they've got Cisco small business gear. And I'm like, hey, we can do this with RIP. And after everybody smiles and realizes I'm serious, it's like, hey, this actually worked out to be a pretty good solution. So let's do a flyby, right? I set this up in GNS3. I was actually rather proud of that topology. And got secure CRT connections to every one of these devices. I'm going to start off on router 1, show IP route, and you can see the only thing we've got is essentially the connected interfaces. Let's get an internet link going, and this is not RIP. I'm going to do IP route all zeros and go to 68.110.171.97. Alright, let's just do a quick ping. 4.2.2.2, make sure we can get there, and ping 8.8.8.8, and we can get there. Now those, by the way, you might say, that's amazing for GNS3. Well, it's actually a router. I set up an ISP router with some loopback interfaces called 4.2.2.2 and 8.8.8, so it actually isn't that great of an internet connection. But let's go in and configure RIP. I'm going to go into global config mode. Router RIP, right? First thing is version 2, so you get that multicast support, and you can also go classless. And I'm going to do no auto, so it's not going to do the auto summarization. And then network, 192.168.1.0. No wildcard mask supported here, because it is by default a classful protocol, so I'll just allow it to do the class C. If you've got 10 networks, like let's just say we've got network 10.1.1.0 on one side and 10.1.2.0, you can only run it on both. You can use the passive interface command, right, to say I only want to run it on one or the other, you know, or send updates on one or the other using that command. So router 1, I think we are good. Let's hop over to router 2. Now again, router 2, we've got the connection to 192.168.2 and 1. So I'll go in there and just do config T, router RIP, version 2, no auto, network 192.168.1.0 and 2.0. And now I've got hello messages. I give RIP too much credit. I have multicast messages going between router 1 and router 2. Let's do a show IP route. Actually, I probably won't see anything because router 1 isn't telling router 2 anything it doesn't know about. So I'm all about making RIP a little smarter. Let's go up to router 1. And a lot of people don't know this command exists for RIP. I'm going to type in default information originate. A lot of people know that from OSPF, where it takes a default route and advertises it into the process. Matter of fact, RIP has another one that says default information originate always. RIP doesn't have that capability. Always says advertise the default route even if you don't have a default route in the table. Just pretend like you do and tell everybody about it. So you should be able to go over to router 2 and do a show IP route here and see, ching, look at that, RIP routes coming in. So now I should be able to ping, actually I won't be able to ping 68.171.97, the ISP. Why not? Who can take a guess? Because the ISP doesn't have a route back to me, and we don't have NAT going on, right? A real internet router should have NAT. Oh, come on. Who's coming? We got to do, I know it's a RIP flyby. Let's do it. Come on. Serial 1 says show. Let's see how fast we can go. IP NAT outside. Interface fast 0.0. IP NAT inside. Need an access list. IP access list. Standard. Let's call it NAT. We'll do permit. 192.168.0.0, so all those addresses, 0.0.0, no, 255.255. Oh, brief slowdown right there. Can't slow down. IPNAT inside source list NAT. We'll go to the interface 01/0 and overload that bad boy. That should do it. Come on. Record time of NAT. Woohoo! Ping 4222. Woo! So that's it. I know. It's a bonus. I just had a guy tweet me not too long ago. He's like, I can't get enough networking ever since I went through CCN. Anyway, it's addicting. So, show IPNAT translation. I can't leave it alone. Yes, we actually have things going through. Okay, good. Okay, so we've got RIP going on now between router 1 and router 2, but router 3 is lonely. So router 3 is connected to 192.168.2.0 and 3.0. Let's make magic happen. Going to global config mode. Router RIP. No auto. Version 2. Network 192.168.2.0 and 3.0. Good. Show IP route. Yes. We've got the route showing up. This guy should be able to ping all the way through because we've got NAT happening. Let's do the ultimate test. Down to PC2 right there. I will do show IP. Make sure it's configured. Good. Ping 4222. Trouble. Oh, wait a sec. No? Wait a sec. Why is that not working? Ping. It should work, right? 8.8.8.8. It's 192.168.3.50. All right. Well, hey, it's a T-shoot series, people. Let's do it. I'm gonna first off let's see how far we can ping. This was not scripted, by the way. Ping 192.168.3.1. Okay, we can get there. Let's do. Let's see if it's getting to router 2. 192.168.2.1. Okay. 1.1. Oh, okay. No, it's getting there. And then, can I ping all the way through to, I should be, now I'm really confused, 68.110.171.98, yeah, and then 97. All right, come on. If it can get that far, it should be able to get to 4222. Well, my friends, that was troubleshooting right there. We just was too impatient on the ping commands. Well, I guess good news is it is working, and we should be able to see that show IPNAT translations, all those guys going through all the way from that host address. It is good. Okay, good. Now, what else can go wrong with RIP? Well, as with any routing protocol, there's plenty that can go wrong. First off, interface being shut down or typing in the wrong network command. Newbie mistake a lot of times is people think the network command they type in, like if they type in network 192.168.0.0, will be what's actually advertised rather than it's using that to just advertise the subnets underneath that, the actual networks that are on the interface. You could have a passive interface that you forgot about. So you type in passive interface command or use passive interface default, which shuts off all interfaces except the ones where you type in no passive interface. That can cause a lot of things to go wrong. And imagine, again, on a T-shoot exam with a large topology, a lot of different players involved, it's easy to miss a passive interface serial 0/0 and then realize, I'm not receiving routes at one direction or another. You could have the wrong RIP version, like one you forgot to type in version 2, and the other one you do have version 2, which is completely different. Broadcast versus multicast, they're not going to see routes whatsoever. One other thing to mention on the passive interface before I forget. RIP is unlike other routing protocols because it doesn't form neighbor relationships. So using a passive interface when both interfaces are enabled for RIP will leave you in kind of a one-way network situation where maybe this guy sees the routes on router 2, but he doesn't, I should say router 2 sees router 1's routes, but because he's passive, he doesn't actually send any routes the other way. So it's kind of weird, whereas anything else, it disables the hello messages and you don't form a neighbor relationship at all, right? Maximum hop count. Who can tell me? Come on, quick test. How many hops away a RIP network can be? Probably got it. 15. I almost stumped it myself. It's 15, right? Yeah, 16 is an unreachable network. So the furthest possible network away you can have is 15 hops. So if you go beyond that, then you can end up missing networks. Auto summarization and load balancing. Two different things that you can run into. Auto summarization is on by default. So as soon as you change classful networks, like I'm going from a 100 network over to a 192 network or to a 172.16 network, it's going to try and auto summarize it back to its classful boundary as long as you have that auto summary turned on, which in my example I turned it off, right? That can lead to a lot of weird and unusual results because you might end up having, a network split where you've got a bunch of 100 networks up here and a bunch of 100 networks down here, and then there's a 172 network in the middle, right? It's going to end up auto summarizing both directions, and you're going to end up with strange results. You might end up with load balancing kicking in where a device up here is going both directions to reach the same network. So best rule of thumb is to always auto, I can't even say it. Now, you know what I mean. Turn it off. Other thing worth mentioning on load balancing, if I can speak again, is let's just do a quick show IP protocols, right? You will see that RIP will load balance over a maximum paths of 4 by default. Now you can go into RIP, I can go into router RIP and do maximum paths and set it to 1, which sounds like something they would really do on a T-shoot exam. If they were, just trying to throw you off, where they're like, hey, we thought we were getting, user A is complaining that he has a slow connection, which is surprising because they have redundant ISP connectivity. You know what I mean? They'll phrase it in there or something, and they'll throw this maximum paths of 1 in there to where you'll have one redundant path that's not used at all. RIP will load balance across 4 equal cost being hop count, cost paths out of the box. You've now seen how to troubleshoot RIP version 2. I hope this has been informative for you, and I'd like to thank you for viewing.